Hello guys, welcome back. We are doing the third video of 3 for related rates for lesson number 6, and in this video I'm going to do 3 different examples of related rates than the first 2 videos. So right now we've done 6 types of related rates, or 6 variations, and we're going to do 3 more today, and that will be enough for this lesson. So if you guys look at question number 8, it says if the base B of a triangle is increasing at a rate of 3 inches per minute, while its height h is decreasing at a rate of 3 inches per minute, which of the following must be true about the area of the triangle? So I feel like I've always told you guys to read the question first before actually doing it, so I just, for the first time, actually decided to do that. So let's go ahead and look at our triangle, and we have a height, and then we have our base. So here's our height, and here is our base. And so it's telling us that the base of a triangle is increasing at a rate of 3 inches per minute. So that means that the change in the base with respect to time is 3 inches per minute. And it's saying that the height is decreasing. So the word decreasing here means that it's negative. So the change in height with respect to time is negative 3 inches per minute. And so we want to talk about the area of a triangle, and so which of the following must always be true if these two circumstances are occurring. So let's take a look at it. Well, area of a triangle, this one I may not give you guys. I think we know how to find the area of a triangle, but it's going to be A equals 1/2 BH. And so what I want to do here is notice that my choices are A is always increasing, it's always decreasing, it's decreasing only when this occurs, or decreasing only when this occurs. So I want to know what's happening to the change of the area with respect to time. So what's a general behavior of the change of area when I have these two conditions? So the first thing that I'm going to do is I'm going to implicitly differentiate this because I need to introduce my dA over dt to my equation. So dA over dt is going to be the left side, because again, this is just a variable. It's just like x, the derivative of x is 1, but again, because we're area, it's the change in area with respect to time. And then I'm going to go ahead and do the 1/2 here, and I'm going to just put a little parentheses because we have to use the product rule here, right? We have 2 terms, 2 functions that are being multiplied together. So we're going to do the first times the derivative of the second, and then plus, okay, remember product, p plus the second times the derivative of the first. So that is our, that's the h and that's the b. It kind of looks a little bit weird. So there is our equation. And so let's go ahead and go a little bit further with this now and plug in the 2 things that we know, right? So you have the change in area with respect to time is equal to 1/2. And then I know that b is fine. The change in the height is -3. And I know that h will leave, and the change in b is going to be 3. So I'm getting some idea now of what I have to do here. So what I'm going to do is, to finish this problem up, I'm going to pull out, and stay with me here with this, because I have enough information now. I'm going to go ahead and pull out a positive 3. Right? I'm going to undistribute a positive 3 here. And I know I see it. There you go. So when I pull out a positive 3, then I have h, right? And then I've got minus b, right? So I pull out a positive 3. I don't want to pull out a -3 because I don't want to deal with the negative on the outside. So I pull out a positive 3, and so I just reword this as h minus b. So let's look at this. So is it always increasing? Well, no, we don't know the relationship between the height and the base. Is it always decreasing? Again, we don't know what's going on here. So we know it's got to be C or D. A is decreasing, okay, which means it's negative when B is less than A. If B is less than H. If B is less than H, this is going to be a positive value, which means that the change in the area is going to be increasing. But when B is greater than H, B is greater than H, so let's say H is 3 and B is 5, you're going to get a negative value here. And so that means that this will be true. A is going to always be decreasing when B is greater than H, right? Because this is going to give you a negative value. If B is less than H, this is going to give you a positive value. So we can't always say it's always increasing or decreasing because we have to depend on what the values of the height and the base are, right? So we know that the answer is going to be D. That's only decreasing when this value here is going to be negative, because this value can be negative or positive. So again, that's what eliminates these two right here. All right, so hopefully you guys got that one, and let's move on to question number 9. So I told you guys in the previous videos that they give you guys area, volume, equations, and this is kind of what you see with these problems. So let's go over this one. It's a little bit different than what we've done before, but I know we can handle it. So again, I'm going to read the question itself, and then I'm going to kind of process what it's asking us to do. It says the radius of a sphere is increasing with a uniform rate of 0.3 inches per second at the instant when the surface area S becomes 100 pi square inches. What is the rate of increase in cubic inches per second in the volume? Okay, so let's go through this and kind of decipher what we know from the problem, and then we're going to go ahead and see what we can do to solve it. So it says the radius r is increasing. So as soon as I see the radius r and then increasing at a rate of, so I know that the change in the radius with respect to time is going to be equal to, and again, it's increasing, so the value is positive, 0.3 inches per second. Okay, and by the way, I don't think I've mentioned this in any of the videos yet. You don't have to write all of this stuff out. You can just go ahead and solve the problem. But since I'm teaching this to you guys, I would just like to have it out so we can kind of see what we need to do. But if you don't, you're not required to have to write the stuff out. Okay, so S becomes 100 pi. So the surface area is just 100 pi. So in this particular example, we want to know what's happening when surface area becomes 100 pi. And then what is the rate of increase of our volume? So we want to know what's the change in the volume with respect to time. Okay, so that's what we need to know. So I'm going to go over here and look at this equation because I need the change in volume, so I need the equation to actually use that. So we're going to go ahead and implicitly differentiate this. So the change of volume with respect to time is equal to, we've actually taken this derivative in the previous video. So again, we would use the power rule. We'd move the 3, because remember, this is just a number. 4/3 pi is just a number. We'd move the 3 down, and so we would get 4/3 times 3, which is just 4. Leave pi alone, we would get r squared, and then dr dt. Okay? So we're trying to figure out what this guy is right here. We don't know what this is. We also know that dr dt is 0.3, but we don't know what the radius is. We don't know what the radius is. So we have two problems here that we don't need to know. We know to find this one, but we got to figure out how to find r. Well, that's where this guy comes in, because usually they don't give you too much extraneous information. So since I know that the surface area that we're looking at this time is 100 pi, I can now use this equation and set s equal to 100 pi, and then I get 4 pi r squared. And just as simple as that, ladies and gentlemen, they tell us what we know what r is. We know that the pi's are going to cancel. We know that when we divide 4 from 100, we're going to get 25. And then we're going to get that r is going to be equal to positive 5, because it's a radius, right? We can't make it negative 5, so distance is not negative. So now I know that the radius is 5. So now I have enough information for us to actually solve this problem. So dv dt is equal to 4 pi, now times our new radius, which is 5, squared, and then 0.3. And so we'll go ahead and do this. We know that this is going to be 25. 25 times 4 is 100. 100 times 0.3 is just going to be 30. So this is going to be 30 pi. And so the answer is D. Two equations. And in this particular case, we used both equations. Are you guaranteed to have to use them both? Most likely, yeah. I mean, they give you what you need. All right, so one more question and we're done with this lesson. So hopefully you guys are all good with it. Let's go on to the next question. Okay, so I've went to the worksheet that I have in you guys' packet to question number 10 and 11. I'm only going to do question number 10 because the rest of these questions you've seen before. So this is another one that I just want to show you really fast. And it's just the same thing with Pythagorean Theorem. It's just a different version of it. So it says a fish is being reeled in at a rate of 2 feet per second by a fisherman at Burke Lake. If the fisherman is standing on a dock 30 feet above the water, how fast is the fish moving through the water when the line is 50 feet long. All right, so we're just going to do that question number 10, and then you guys could obviously do number 11. So we're going to take a little bit of liberty here, a little bit of assumptions to be made is we're going to assume that the fish, we're going to assume that the fish is basically at the water level. So this 30 is going to be represented here. We're not going to incorporate the distance between the water and where the fish is. So that's why I'm doing this problem, because that's what they're going to assume. We're also going to assume that this distance right here is going to be, so the hypotenuse of the right triangle is going to be the line. The line's out. So we have that this is 30, and we know that this is 50. Okay, and yeah, you could have drawn the triangle, a little bit higher up, but again, we're not going to take into account the little width of the height of the guy. So we have this, and you guys can see clearly it's a right triangle. So we're going to use Pythagorean Theorem yet again. So x squared plus y squared is equal to z squared. And I go ahead and tell you guys, I just immediately write down this already implicitly differentiated, because it's going to be the same thing all the time. All right, so there we go. And so we got to figure out what we know and what we don't know. All right, so let's look at x. So x is going to be this distance right here. Well, Pythagorean Theorem tells us what this is, right? Just think about the 3, 4, 5 triangle. 3, 4, 5, 30, 40, 50, 30, 300, 400, 500. So this is 40. So I know that x is going to be 40. So let's go ahead and put down x is 40. The change in x is a fish is being reeled in. So that is, so a fish is being reeled in at a rate of 2 feet per second. So remember that this is the actual fishing lure, right? This is the actual lure. So this 2 feet per second is actually the change in z, right? So this is is it just 2 feet per second? And then that's it. That's all we give. So it's asking us how fast is the fish moving through the water. Okay, so there we go. So how fast is the fish moving through the water? So that's actually what we are trying to find, the change in x, right? Because the fish is going this way through the water. So we don't know what that is. So dx dt is this problem. Y is 30. We do not know what dy dt is, but we do know what dy dt is. Hopefully you guys already know what it is. Remember that the guy is on the dock and the water's here. And again, we're making the assumption that we're not taking into account that the water is actually, moving up and down, wavy. So we can just assume that this right here is going to be 0. So we know that the change in y with respect to time is going to be 0. All right, so that's that. Z is 50, and we already know that this answer is going to be 2. So when we look at this problem, all we really care about is the 40 dx dt and then the 50 times 2. So we get 40 dx dt equals 100. And so all we have to do to find the change in x with respect to time is take 100 divided by 40, and we get 5 over 2. And then the units are going to be feet per second. And it's just that simple. So this example, not one of my personal favorites, but, because there's a lot of assumption that we made here, a lot of assuming, but this is the idea for it. And that's it. So hopefully you guys are now related rate experts, and we will meet back together in the next video. So see you guys then.